You are listening to the Break Time Tech Talks podcast, a bite-sized tech podcast for busy developers, where we'll briefly cover technical topics, news snippets, and more in short time blocks. I'm your host, Jennifer Reif, an avid developer and problem solver with special interest in data, learning, and all things technology. We talked about vectors in both episodes 5 and 10 of this podcast, and I want to continue this topic just a little bit to explain how we would search these numeric representations of data, and then some tips that I've picked up this year about vector search. Then I'll give my thoughts on a couple of tech conferences where I've spoken in the last couple of weeks, both Java conferences with some similarities that felt to be a nice change of pace to some other events that I've been to over the years. The first topic for today is looking at vector search. So when we talked about vectors, just to recap, they're a list of numbers that represents a term or a piece of data, a piece of audio, video, document, text, you name it. Really, we can create a numeric representation that sums up and creates a unique value for different features and characteristics that we understand about that piece of data. This means that we can compare these and look at how similar they are or even search them. But this gets really cumbersome if you think about creating an embedding or a vector for every bit of data that you might have in a system or a company or the internet or so on. There's a lot of data. How can we make this easier to search? Databases will use an index to find data quickly. Can we do something like this with vectors as well? You actually can. It does work a little bit differently though. The first thing to understand is that how we calculate similarity depends on the underlying algorithm being used. There's a few different ones that you can use to calculate similarity. The two that come up probably the most in the AI tech space right now is cosine similarity and Euclidean distance. Euclidean distance is the shortest path or direction or line between the two. As the crow flies, if you know that turn of phrase, it's taking point A to point B directly. Cosine similarity, I think, is probably the most popular, looking at the vector, the line, if you will, in space, that again represents all those features and numbers. And it's taking another line in space and comparing how far apart are these two lines. Now remember, we're not dealing in two-dimensional space, we're dealing in multi-dimensional space. What is the multi-directional angle between the two? But then how do I find my point in space? How do I find that single one thing I might be looking for? And the algorithm used is KANN, which is K approximate nearest neighbors, to find the specified number of closest results. It could be anything from 2 to 16 to 65 to 120 to on up, any number, it's infinite. But then it calculates how many similar results to return by the number specified. And then it allows you to return what are the most similar vectors to this one particular vector I'm looking at. So that's how similarity search works in the kind of nuts and bolts space of things. Let's look at a couple of examples to apply this. Think about any streaming service you might have that's entertainment, TV shows, movies, etc. You'll typically type in a keyword for something you want to find or a genre. But if you don't remember the genre, or there's too many results, or you aren't quite sure what you're looking for because all you can remember are a couple of details about the movie poster, you can't really search a movie app like that. It has to be very specific keywords or tagged things or specified words that are available in the metadata. But vector similarity search would allow you to splice and dice different features and characteristics about whatever piece of data you wanted to vectorize, whatever features and characteristics you wanted to highlight out of that particular movie or TV show, and it would allow you to search very narrow niche features. Another example that I really love is a library classification system. I like libraries. I understand how books are classified typically in a library, but most of the time you're dealing with nested categorical structure. You have fiction versus nonfiction sections. And then within each of those, you have different genres and authors and then title IDs that make up a unique place on the shelf for a particular book. However, instead of searching with this nested categorical structure, again, if you had very general concepts, you wouldn't know where to find that book. You might be able to narrow it down to, okay, it's a fiction. Now I have hundreds or thousands of books I have to look through. Is it even here? Instead of that, we can organize by similar characteristics or very niche features. For example, if I wanted to find books or products, this could be a store or a library, maybe I'd want to find something that's based in a specific town or that includes certain qualities about the item. I could search those very specific, obscure things, and it would surface things that are similar, and it would pull back a much smaller search set. Looking for books that are based in a specific town, you're probably only going to have a few, maybe a dozen for a particular place. And that allows me to search and find things much more easily. Smaller search set, much better retrieval time. There are also a couple of tips I've picked up this year on embeddings and vector search. The first is that your embedding model and your search model should match. They don't necessarily have to, but they should at least be in the same model family. So by the same provider and in the general area of same models, right? The reason for this is that every model is going to work with a different number of parameters, and it's going to have been trained on a different set of weights. So some companies or models might prioritize certain things over other things, and they'll weight those more heavily, therefore guiding answers into one area or another. And you might also have different embedding lengths. Some models will take shorter lengths of embeddings. In other words, fewer floats in the list. And some of the models will create a lot larger embeddings. You also have a little bit of a relevance score that will depend on your use case. For instance, something like a movie recommendation, you could return anything that's 50% relevant or 60% relevant or 40. It doesn't really matter, assuming you determine what threshold should be the best results. A little bit of wider relevance for a support chatbot, it might be okay, depending on the type of support you're doing. You might want something that's very highly relevant. That's going to be less problematic, so people find exactly what they're looking for. They solve their problem in a click of a button, and they're done. Where if they have more cluttered results that aren't as relevant, it's going to be harder for them to solve that problem. However, in specific use cases like healthcare or financial advice, relevance is super critical. You want to have only the absolute most relevant results because bad advice in those spheres can be detrimental. Again, it really depends on your use case, how specific and what that tolerance threshold should be. The second thing I wanted to cover is just a little bit of a highlight on two conferences I've attended recently, JConf conference in Dallas, Texas, and then Dev2next conference in Denver, Colorado. There were a couple of things that these two conferences shared. It was fun actually to have them back to back. They were both smaller events, which allowed me to connect with existing colleagues as well as some new folks in the Java space, talk with them on a deeper level because the event was smaller. You didn't quite feel lost in the shuffle, which was nice. Both events were very well organized, very well scheduled. You had plenty of time to learn and chat and a good blend of both. You didn't feel rushed or that you didn't get a chance to do this or that. The food was fantastic. The venues were great. The locations were really helpful to get in and out of town as far as traveling and commuting in. And then coffee was good, which is always super important. They also had plenty of session length. There was 1 hour presentations for JConf and 1 hour and 15 minutes for Dev2next. This was really nice because you had plenty of time to dig into content, really go deep and cover a lot of ground. You could either cover a lot of different topics at a high level, or you could go really deep on one or two things, and you had plenty of time to showcase those. So this was really, really nice. There were a couple of differences between the two. I'll just highlight, and again, not saying this is bad or good. I enjoyed aspects of both of these. JConf had a little bit more diversity in topics for the Java space. Some were high level, some were a little bit more specific. It was really nice to get an overview of a little bit of everything. And if you wanted to dive deep on one particular topic, there were some nitty-gritty things as well as some high level stuff. A good mixture there. Dev2next some of the session topics overlapped, which was really good for reviewing and refreshing concepts that maybe you had heard before or hadn't gotten back in touch with in a while. It was also really helpful to pick up new tidbits and hear different speakers' approaches and tactics and things that they had picked up on similar or same topics there. These sessions also tended to have broader topics. Many of them focused on AI, but there were also some other things represented there. There was a little bit of everything, I felt like, but on a general scale, I would say they were a little bit broader in nature. I'm learning every day, and one thing I really enjoy doing is passing on those little nuggets of information to other developers. This week's highlights discussed how vector search works, along with some examples and tips that I've picked up, and then talking about my experiences at the recent JConf and Dev2next Java events. Whether you're considering these or other events, I hope my experiences might help you pick and choose what appeals to you most. Thanks for listening, and happy coding.